Hello everyone, this is Ali, Lab 3 Magnetic Field of a Bar Magnet. The goal of this lab is to use a Biot-Savart law and GlowScript to compare distance dependence measurement from experiment. Concepts used in this lab, the first one is the Biot-Savart law, and I have the formula here where we've used it to find the value of B. And the distance dependence equations where we measure the value of B. We have the Kr and we try to calculate the value of N. And here are the results. So the first one is the N is negative 2.74 and the value of B is 5.06. And now I'll go over the experiment real fast. The first part of the experiment was to locate where the magnetometer chip on the phone is. And after using the procedure indicated in the lab, I found it to use the phone like this, and I measured the different values of B on different distances. And after that, I laid it on the spreadsheet. The first values of the data here we can find, so here are the different distances and the values of B measured. And here is the slope where I got negative 0.274. This is the value of N. The second part of the data where we measured the value at the perpendicular to the axis instead of on axis. And here are the values. Now I'll go over the coding real quick. I left the GlowScript code in the submission if you want to go over the coding. Now I'll go briefly on what is the goal of the coding and what are the results. So the goal of the coding is to, as indicated in the introduction, is to find different values for B on axis and perpendicular and at a 45 degrees, and then visualize it in different arrows. So we got the orange arrow is the one on axis. You can see that we have only one arrow and two values. And the reason for that is we have two similar, the same values. And from this angle, we can only see one arrow. And this is the orange is for the one on axis, and the one perpendicular is with the cyan color. And as you can see, we can only see two arrows, and it's for the same reason. We have all the same values. And at 45 degrees, the one on purple here. Now we'll go to the what if questions. The first one, what if you hadn't oriented your experiment to compensate for magnetic north and had instead laid out your meter sec at some intermediate angle with respect to Earth's magnetic field? How would your result have changed? The magnetic field values would be less accurate since the Earth's magnetic field is interfering with the values measured. And the second question, what if you were to stick two identical magnets together end to end and run the experiment again? How do you expect your measurement to differ? The answer for that is the magnetic field, the magnitude of the magnetic field would increase. In fact, it would double, but it will be still at the same direction. In conclusion, the magnitude of magnetic field to power magnet decreases as distance increases. And here are the values that I got from the experiment, the value for B and value for N. Thank you.